And for the record, say and spell your first and last name, please.
Randy Zepeda. RANDYZEPEDA.
Thank you. Sir, can you tell us how it is that you're employed?
I'm employed by the Los Angeles Police Department, Forensic Sciences Division.
And are you assigned to a particular area or division within the lab?
Yes, I'm assigned to the Serology DNA unit.
And how many years have you been assigned to the DNA unit?
About 15 years now.
What is serology, if you could tell us?
Serology is kind of just an antiquated term for the analysis of biological fluids.
And what is DNA?
DNA is a molecule that's found in most of the cells of your body that acts as like a blueprint for your body. So it tells your body not only how to build itself, but how to function. DNA is unique to every individual, aside from identical twins.
And it remains the same throughout our life? In other
Yes.
words, if you were to take blood or a oral sample, what's referred to as a buccal swab, that would remain, my profile would remain constant?
Yes, as far as the forensic DNA profile, that remains constant throughout your whole life.
Okay. What are your responsibilities within the DNA serology unit?
In the serology unit, we deal mostly with biological evidence. So my job is to identify any potential biological evidence, sample that evidence, preserve it, analyze it. I'll issue reports. I'll also technically review reports issued by other analysts and work completed by other analysts, and I'll testify in court to those results.
And you generate reports yourself?
Yes, ma'am.
Okay. And in terms of the DNA process, has that changed throughout the course of your work on this case that you're here to testify about?
Yes, it's changed in the fact that we look at more locations in our DNA now, but the overall process is still just about the same.
In terms of the process itself, is the DNA process within your lab and other crime labs across the country done by instrumentation in terms of various steps in the process?
Yes, some steps are more labor intensive for the analyst than others, but for the most part, most steps we use some sort of instrument or liquid handling robot to assist us in performing our analysis.
Now, we heard earlier about, from Jane Kwon, about the lab certification or accreditation process by an individual outside agency. Are there certain standards and protocols that you follow within the DNA or serology unit with respect to methodology, validation, instrumentation, and things like that?
Yes, there is.
Okay. And in order to ensure that the results that you obtain are reliable, accurate, and are reproducible, do you follow, again, a certain protocol and with respect to every single case that you touch?
Yes, we have protocols in set for every procedure we perform in the lab.
And with respect to this case and all cases in general within the serology unit, are case files generated that contain all of your results as well as the results from any of the instrumentation that is utilized during the process of developing, let's say, DNA profiles?
Yes, so with any case, we produce a case packet, and basically, like you said, that's a packet of all of the documentation that we produce for that case. So it can be handwritten notes from observations we make in the lab of the evidence, or printouts from instrumentation that we've used to perform various steps for analysis. We maintain all of those in one place, one case packet. And this is my case packet here today, so I bring it even just to reference what I've done in this case.
And in terms of the DNA unit or the serology unit itself, are there also quality assurance measures or controls that are in place for, let's say, purposes of contamination?
Yes.
Contamination.
Yes, there are.
Can you tell us briefly about those?
Yes, some quality assurance measures that we take into place are things like wearing personal protective equipment. So personal protective equipment not only protects us from the evidence, but the evidence from our own contamination. So we'll wear things like masks, we'll wear gloves, we wear laboratory coats, sometimes we'll even wear hairnets. And these things we change, especially our gloves, in between handling different items of evidence. We also do things like analyzing evidence samples separately from reference samples.
Let me stop you just there, and we'll move on to the rest of that answer, but you just brought up something important. Can you explain to us the difference between a reference sample and an evidence sample?
An evidence sample is an unknown sample. So it's something that we locate at the crime scene, or we sample off an item, and we don't know the source of that sample. We don't know where that DNA might potentially come from. A reference sample is a known sample. So that's a sample that's taken directly from an individual to use for comparison to an evidence sample.
Do reference samples tend to come in the form of one or two different sources?
Yes, in general, we get reference samples that are usually oral samples, so swabs of the inside of your mouth, or blood reference samples, which are blood cards that are generated by the coroner's office.
And do you test evidence samples on separate times from reference samples? So again, not to cross-contaminate the evidence?
Yes, so we analyze references completely separate from evidence samples.
Okay. Back to some of the quality assurance measures that are in place in the DNA section. Is the DNA section in the lab itself also secure facilities and areas?
Yes.
And does the DNA section also maintain a database where, if, let's say, you were to get a profile that you didn't expect, or that you could run through the database that contains criminalists from the crime lab, their DNA reference samples to cross-compare to ensure that you're not putting your own DNA into a sample?
Yes, we do maintain a quality control database that has even my own reference sample contained with it, where we can check when we get unknown samples or an unknown DNA profile from the sample that it's not our own contamination into that item.
And in terms of your work, is it also peer-reviewed?
Yes.
What does that mean? What does peer review mean?
Peer review means that all of the work that we complete gets re-looked at by another analyst. So even from forms that we generate to my final case laboratory report that I generate, a second analyst will go through, look at each one of those items, and they'll sign to attest that essentially they would come to the same conclusions that whoever is authoring either that page or that report came to. In addition to the peer review, we also have an administrative review process, which is a second review by someone like a supervisor, but that's more for the content of the report, as well as things like grammar and spelling, things like that.
And all of that is done for the purpose of what?
To maintain the accuracy in our results.
In terms of the certification within the DNA unit, are you required to undergo proficiency testing on a regular basis?
Yes, twice a year.
What is proficiency testing?
Proficiency testing is a test that's administered to us by an outside agency. They know what the results of the test are, we do not. And we treat it essentially like a regular case. So I would analyze it as if I was analyzing a evidence sample from a crime scene. I produce a report, and all those reports and results go back to that outside agency, and they'll say, yes, you performed these tests as expected, you obtained the correct DNA profiles, you made the correct comparisons.
Can you tell us a little bit about your education, training, and experience that qualifies you for your position in the lab?
Yes, I have a Bachelor's of Science in Biology from the California State University, Los Angeles, as well as Master's of Science coursework in Biology, also from the California State University, Los Angeles. I've attended several trainings with the California Department of Justice, California Criminalistics Institute, in the fields of forensic biology, as well as forensic DNA typing. I've also had separate in-house LAPD training in forensic biology and forensic DNA typing. Those were both years-long training. ever since I was initially trained, I'm also required to attend continuing education courses at least once a year. So since I became a DNA analyst in 2013, every year I've taken an additional course of continuing education since my original training.
Approximately how many case samples would you say you've analyzed using DNA typing techniques?
Tens of thousands.
And have you also qualified and testified before with respect to DNA analysis and the results multiple times?
Yes.
Tell us what is, or describe for us what is DNA typing.
DNA typing is essentially producing a DNA profile from an unknown or reference sample. Now, a DNA profile is essentially we're looking at different locations in your DNA. Currently, we look at 23 different locations plus a gender marker. These are locations in your DNA that are variable, so they're different from individual to individual, but like I mentioned earlier, they're also stable throughout your lifetime. Now, at each one of these locations, you have essentially two numbers. So let's say looking at the first location, you'll have two numbers. One of those numbers you get from your mother, one of those numbers you get from your father. And we'll look at all of those 23 different locations. We essentially get those number pairs for every single one of those locations, and that is your DNA profile. And we can use that to compare it to, like I said, items of evidence. We can compare it to other DNA profiles. And we can, from there, even calculate statistics on how rare that association is.
Is there a standard procedure that's utilized in the crime lab and the same across, let's say, the country or maybe even the world that is used to develop a DNA profile, whether it be from a reference sample or an evidence sample?
In general, yes, the procedure is pretty much the same no matter which lab, forensic lab that you're working in. Now, the different chemicals that we use or instrumentation might be different, but in general, the process of obtaining a DNA profile is pretty consistent, not only throughout the country, but throughout the whole world.
And are there particular steps that are used in processing samples?
Yes.
What's the first step?
The first step in general in processing a DNA evidence sample is extraction. Now, extraction is when you take a sample. So in any given case, I'll have, let's say, several tubes labeled with case identifiers for that specific case, unique to this case, and I'll add some chemicals to it. And what those chemicals do is they break open the cells and release the DNA from the cells. Now, after the DNA is extracted from those cells, I can run it through a different instrument or a different robotic instrument to clean up that sample, essentially removing all the other cellular junk and proteins, just leaving the DNA behind.
Okay. What's the next step?
The next step is quantitation. That's when I take that sample I produced after that first step and I measure how much DNA is in that sample. We need to know how much DNA we have so we can know if we can move on to the next step or how to basically treat the samples for that next step.
You need a certain amount of DNA present in order to run the DNA test, correct?
Yes, we have a minimum amount of DNA that we need to even attempt to obtain a DNA profile, but there's also a range of DNA that we target for our next step.
And your laboratory and section set thresholds for minimum amounts, correct?
Yes.
Okay. What's the next stage? Let's say you were to be able to determine that you had sufficient DNA to proceed. What's the next stage?
The next step would be amplification, where we make copies of the DNA that we have, and these copies are kind of special. We add basically markers to them, fluorescent markers, so we can visualize those copies in the final step, which is the DNA typing step.
And you said the final step's the instrumentation set.
The final step is our DNA typing, but we used instruments to visualize that DNA.
Okay. So when you initially started your work on this case back in 2017, was it, did you look at a different number of markers or locations on the DNA than you do now? You told us now you use 23 plus a gender marker. What was the number back when you first started out doing testing on this case in 2017?
In 2017, we looked at 15 different locations plus a gender marker.
Okay. And what was the testing kit that you used in 2017?
We used a kit called Identifier.
Okay. And that was the industry standard at the time, correct?
Yes, many labs use the Identifier kit.
And going forward, at some point, your lab, as well as other labs across the country, transitioned, as you talked about, to these testing kits where we now look at 23 different locations. Plus.
Yes, all labs were federally mandated to begin to use an expanded kit. So we switched to a kit that looks at 23 different locations plus the gender typing.
What kit is that?
That is Fusion 6C.
In terms of the evidence that you processed in this case, did all of that take place under a particular LAPD case number, DR number?
Yes, ma'am.
And was that DR number 17-21-5194?
05194.
Okay. And did you also receive, or were you provided with reference samples in this case?
Yes, I was.
Back in 2017, were you provided with a reference sample or an oral swab for an individual by the name of Robert Baker?
Yes, ma'am.
And was that identified as item number 158 under this DR number for this case?
Yes, it was.
Okay. At some point subsequent to the reference sample for Robert Baker, were you also provided with an oral swab or a reference sample for defendant Monica Sementilli?
Yes, I was.
And was that identified under that same DR number as item number 201?
Yes, it was.
Did you also receive numerous blood stains from a crime scene collected by Kori Hawk?
Yes.
And did you know Kori Hawk from the lab?
Yes, I did.
Was she somebody that worked in your field identification unit, someone that would go out to crime scenes and process crime scenes or vehicles or things of that nature?
Yes, ma'am.
Did you also receive a collection of swabs from a Jane Kwon, who just left the courtroom as you came in, from the victim's Porsche?
Yes, I did.
Did you develop profiles for the reference samples in this case?
I did.
Did you also, at some point in time, receive a reference sample for the victim? I think you talked about reference samples that you normally get from the coroner's department. Did you get one from the coroner's department in this case?
Yes.
And again, was that a bloodstain card for victim Fabio Sementilli?
Yes, it was a reference blood sample.
What item number was that?
That was item 72.
Okay. So that was your a third reference that we talked about so far, correct?
Yes.
Okay. And did you develop profiles from the evidence samples that you received from Kori Hawk?
Yes.
Did you also develop DNA profiles from the evidence profiles you received from Jane Kwon?
I did, yes.
From the evidence samples you received from Jane Kwon.
Yes.
And then once you developed profiles from all of the evidence, did you make a comparison over a course of many years to the reference sample profiles that you developed?
I did, yes.
And did you write numerous reports in this case?
Yes, ma'am.
All right. I want to start with your initial report from February 9th of 2017. Did you reference in that particular report evidence samples from the crime scene as well as the Porsche?
Yes, ma'am.
And did you screen various evidence samples that you received from Kori Hawk for blood?
Yes.
And did the evidence samples that you received from Kori Hawk screened positive for blood?
Yes, these were positive for a presumptive test for blood. Yes.
Same type of chemical test that would show you a particular color if it tested positive for blood?
Yes, it is a color change test.
Back to your February 9th of 2017 report, did you determine that there were samples that matched the victim's DNA profile in this case?
Yes, there was a sample that matched the victim's profile.
Or samples?
Yes, from this initial report, there's only one sample that initially matched the victim's profile.
Show you an exhibit that's already been marked as People 7. Has a 3 in the lower left corner. Do you recognize what you see here?
I do.
And what is this?
This was a exhibit that was created by our architectural drafting aid to demonstrate where different items of evidence were located at the crime scene.
All right. And there's also a key to the right that identifies item numbers by the photo ID number along with whether or not they screened positive for blood and then were marked as red versus items that did not and therefore black. Is that correct?
Yes.
And did you work with the individuals in the architectural unit or at least review this particular exhibit previously to determine its accuracy?
Yes, I didn't help create it, but I did review it after they created it.
And was it accurate in terms of the results that you obtained?
Yes.
Did you also review, in this case, crime scene photographs with respect to a location where the victim was murdered?
Yes.
Okay. And in reviewing those crime scene photographs, did they assist you in determining which particular swabs may be more fruitful to test for DNA, depending on where they were located and what that area looked like?
Yes, ultimately it's up to the investigators which samples we analyze, but me conferring with the investigators, I can give them an idea of what are the best items to choose for DNA typing.
Okay. So you confer with detectives, prosecutors, to assist in narrowing down the selection?
And mostly just detectives, but yes.
Okay. Looking at People's 7 that has a 39 in the lower left corner, if we look at PID number 18, which appears to be that circle of red, PID 18 on the counter area, is that one of the items that was tested?
Yes.
By you?
Yes.
And did that, again, screen positive for blood?
Yes, it screened presumptively positive for blood.
And did that stain match the victim's reference profile or DNA profile in this case?
So for this specific item, picture ID 18, we received a partial DNA profile, and that was consistent with the DNA profile of Fabio Sementilli.
Okay. Showing you what was previously marked as People 7, it has a 49 in the lower left corner. The entryway to this crime scene at the front door. If we look at what's been tagged there as PID 23, again, looks very similar to the circular red stain that we saw on the counter. This area here, was that another sample that tested positive for blood?
Yes, it tested presumptively positive for blood.
And again, did this particular item match to the victim's DNA profile in this case?
Yes, this was also a partial DNA profile, and it was consistent with the DNA profile obtained from Fabio Sementilli.
193 with an 8 in the lower left corner. Is this another architectural diagram relative to the victim's Porsche that you previously reviewed in this case?
Yes.
And just like the legend or key that we saw with respect to People's 7, number 3, the diagram of the crime scene, does this legend here that we see at the top also appear to be consistent with or accurate for the results you obtained with respect to what tested positive for blood and what did not?
Yes, I did previously review this diagram.
What's been previously marked as People's 193 with the 20 in the lower left corner. In addition to the crime scene photos, did you also review photographs of the interior, the driver's compartment area of his Porsche?
Yes, I have seen them.
Okay. And with respect to what we see here, PID 23, the brake or the clutch, I think it was referenced as a brake pedal initially and then changed to clutch. Again, was that another swab that screened positive for blood and matched the victim's DNA profile?
Yes, so this one actually screened presumptively positive for blood, and this was a complete profile. So this was a DNA profile from one individual, a complete profile, and that one matched the DNA profile obtained from Fabio Sementilli.
If hypothetically someone walked through the victim's blood and tracked it into a vehicle, would this be commonly an area that you would test for potential DNA?
I mean, yes, if somebody walked through a bloody crime scene and then drove a car away, I would test the car pedals to see if there was potentially blood.
Showing you what's now been marked as People's 195 as a 5 in the lower corner. Do you recognize what you see here?
Yes, so this is a summary of my DNA typing results for several items.
Okay. What do we see here along the left column in white under genetic locus testing? What is that?
So earlier when I mentioned that when I initially started this case, I was looking at 15 different locations plus a melagenin, or the gender typing. These are the names of those 15 different locations, plus the AMEL, which is a melagenin or a gender typer. The profile at each one of those locations, those are the numbers I was talking about. So let's say the top one where it's D8, if you look over at the victim, he's at 1215. So you would have gotten the 12 from one of his parents and the 15 from his other parent. Now if you go down to CSF 1P0, the fourth one down, you'll see there's only 11. Well, that's actually an 1111. So we got an 11 from his mom and an 11 from his dad. We just notated as a singular 11 when they have the same number for both copies.
That's your lab's protocol.
Yes.
So if we go down, let's say to TPOX or VWA, we see that happen again, or D18 or D5, correct? I'm sorry, not D5, just D18, correct?
Yes, so VWA, TPOX, and D18, those would be like, so VWA would be an 1818, TPOX an 88, and D18 a 1515. Now some labs do notate it as the number twice, but we just write the number one time in our lab.
So item 72, that's the reference sample we talked about earlier that you received, the blood card or the blood stain card from the coroner's office for victim Fabio Sementilli in this case.
Yes, that's correct.
So this would be the DNA profile that you developed back in 2017 based on that blood stain card.
Yes.
Okay. And then do you use this reference profile to make comparisons to evidence profiles that you then develop from evidence items.
Yes.
Okay. And if we look at amylogenin, the gender marker, we see here an XY. What does that mean?
XY indicates male. XX or just X would indicate female.
Okay. If we look at the column next to the victim's profile where it says kitchen counter, item 17, that would be the item number under the property report of this DR, correct?
Yes.
And PID would be the photo ID number, number 18. What do we see here in this column?
That's a summary of the DNA typing results for that specific item.
That you obtained?
Yes.
Okay. That's the kitchen counter that we looked at in Exhibit 7 that has a 39 in the lower left corner. Is that correct?
Yes.
And again, you make a comparison between the victim's DNA profile and the evidence item, correct? The profile you developed from the actual evidence item.
Yes, so one of the steps of a comparison is to actually just visually compare those DNA types. So I would go through and look at what's the first location, D8. It's the victim is a 1215, the kitchen counter is a 1215. That's consistent. And I would go location by location. At the end of the evidence profile, you see there's two locations on here that say ND. That stands for no data. These, I indicated earlier, are partial DNA profiles. We didn't obtain DNA profile information for those two locations.
So that's why you clarified and said that with respect to these two samples, the evidence item, you developed a profile that was consistent with the victim, whereas in the third, you actually got data at those locations, D5 and FGA, and you were able to say it's a match.
Yes, so we'll only be able to say match if it's matches at every single location. Now, if we have an instance like this, where we have two locations where we didn't obtain data, we'd only say consistent with.
Also, when you are interpreting the data, you aren't looking at the numbers or the alleles that are reported out. You actually look at the raw data as it comes off the instrumentation itself, correct?
We look at the raw data as it's coming off the instrument itself, in addition to the numbers. They're the summary for each different location. Just because it's, like I said, in simplest terms, one of the steps is to look at the physical numbers that we obtain and compare those numbers. But we also look at things like the quality of the data that we're obtaining. So even though we let's say we have a DNA profile where we get information at every single location, if the quality is bad, then we might not use that for comparison.
And again, we talked earlier about how there are thresholds that are set in the lab. We're not going to get into a whole conversation about that, but any information that falls or data that falls below the laboratory's threshold is information that you may or may not take into consideration in reporting out.
So yeah, so whenever we bring on a DNA typing kit, we always perform a validation study. Essentially what that is we use that study to do things like set thresholds or quality indicators for evidence. We learn how the evidence is going to behave in our laboratory with our equipment. We're able to set thresholds based on that.
And again, if you look over here in the final column, that's from the Porsche, the clutch that we talked about.
Yes.
Okay. Which matches the victim.
Yes.
Okay. I want to move on to a report that she drafted dated July 25th of 2017. Were you provided at this point, or by this point, with the reference sample for Robert Baker?
Yes, I was.
And we talked about that came in the format or the source of a buccal swab or an oral swab from the interior of the mouth.
Yes.
Okay. And did the swab itself, or the swabs that you received with respect to this reference sample for Robert Baker, come in an envelope from LAPD detectives Tellis and Gable that contained identifying information with respect to the individual Robert Baker.
Yes, ma'am.
Okay. And did you develop a profile for Robert Baker?
Yes, I did.
And is it a typical procedure that you would obtain reference samples perhaps at a time later after you receive evidence samples?
Yes, sometimes when I begin analysis on a case, I have no reference samples at all.
Showing you what's now been marked as People's 195 that has a 7 in the lower left corner. Can you tell us what we see here in this column that is blue next to the various locations that are tested?
Yes, this is a summary of the DNA profile of Robert Baker.
And again, if we look over one column, we see a column that at the top says kitchen floor, item 9, PID 9. Is this the DNA profile that you developed for that particular sample?
Yes, ma'am.
Would that be consistent with what we see in People's 7 that has a number 32 in the lower left corner for PID numbers 9? We'll start with 9.
Yes.
Okay. And so this is the DNA profile you developed from that blood stain.
Yes.
We look one over to item 10, PID 10. Is this the DNA profile that you developed from the stain that we see here? Again, People 7 has a 32 in the lower left corner, this blood stain here.
Yes, ma'am.
And on the far right, we see, again, a column that's marked garage floor, item 43, PID 36. Is that consistent with what we see here in People 7? It has a 16 in the lower left corner. What we see here in 36, and a close-up of that red stain.
Yes, ma'am.
And so, did you make a comparison between the reference profile you developed for Robert Baker to these various stains at the crime scene, both in the kitchen, on the floor, and on the garage floor?
Yes, I did.
And what was your determination?
The DNA profiles from these items matched the DNA profile obtained from Robert Baker.
Recess for 15 minutes. The admission applies.
Going back to Exhibit 195 that has a 7 in the lower left corner, we were talking about the comparisons that you made to the stains on the kitchen floor and the garage floor. Can you tell us, with respect to item 9, or PID 9, what were you able to determine?
So this was the swab of the red stain from the floor. This item matched the DNA profile obtained from Robert Baker.
And what about the next item, PID 10, item 10, again, the other stain on the kitchen floor?
This item also matched the DNA profile obtained from Robert Baker.
And if we look at the profiles next to each other, we're talking about the exact same profile, correct?
Yes, you see the same numbers at every single location.
And then the garage floor, the column to the far right, item 43, PID 36, what did you determine regarding that item?
That was the swab of the reddish brown stain from the floor. That DNA profile matched the DNA profile obtained from Robert Baker.
Showing you what's now been marked is Exhibit 195 that has a 6 in the lower left corner. Again, looking at the reference sample in blue, the DNA profile you developed for Robert Baker, but now looking at evidence samples recovered from the Porsche, the left door panel, the interior left door panel, what do we see here? Which should be item 54, PID 11.
Yes. This DNA profile also matched the DNA profile obtained from Robert Baker.
And the one next to that, the left, or the driver's seat controls, which is item 61, PID 18. What were your conclusions about that particular item?
This DNA profile also matched the DNA profile obtained from Robert Baker.
Okay. And again, just for reference, the interior driver's door in Exhibit 193 that has a 14 in the bottom left corner. This is the stain here that you tested, correct?
Yes.
And with respect to the driver's seat control in Exhibit 193 that has an 18 on the bottom left, again, this red stain that we see next to the red sticker with the arrow pointing to the stain.
Yes.
Now, did you, when you say it matched to Baker, you talked to us before the break about being able to calculate statistics to determine the rarity of a particular profile. Did you calculate statistics in this case?
I did.
And what did you determine with respect to all of these results contained in Exhibit 195, 6, 195, 7?
So the DNA profiles obtained from, I'll go through the item numbers, item 43, 54, 61, 9, and 10 occur approximately 1 in 5 quintillion unrelated individuals.
Say it again, please.
1 in 5 quintillion unrelated individuals.
If we hear the number quintillion, I mean, most of us know what a million or a billion or maybe even a trillion, but when we talk about a quintillion, how many zeros are we talking about?
5 quintillion is a 5 followed by 18 zeros.
So what is the current population of the Earth, approximately?
At the time we did this testing, it was about 7 billion individuals.
It's probably somewhat greater than that, but not quite 8, correct?
That's around 8 now.
Okay. So how many times the population of the planet Earth would you need before you would see that number again, that profile?
So if you, Earth, like I said, is at this time was about 7 billion individuals. You would need 700 million populations the size of Earth. So 700 million times what Earth's population is to have 5 quintillion. So on average, we only expect to see this DNA profile 1 in every 5 quintillion unrelated individuals.
Okay, so we're talking about a very rare DNA profile here.
It's a very small number, yes.
Okay. All right, let's talk about a report that you authored that was dated November 9th of 2017 with respect to, again, various samples such as evidence from the crime scene. We look at what's been previously marked as People's 8 that has the number 11 in the lower left corner. Placard or PID number 1, this blood stain that we see here out on the patio area. Did you do an analysis of that stain?
Yes, I did.
And what result did you obtain?
This DNA profile was consistent with the DNA profile obtained from Fabio Sementilli.
I'm sorry, I didn't hear you.
Sorry, it was consistent with the DNA profile obtained from Fabio Sementilli.
Okay. And did you calculate a statistic?
Yes. So in this case, because when I analyzed the reference initially, I was only analyzing 15 locations. Once I got to this request, we had already changed over to looking at 23 different locations. So I only had 15 locations to compare because of the limitation of the reference. So using 15 of 23 locations, this DNA profile occurs in approximately 1 in 2 quintillion unrelated individuals.
So again, you told us a quintillion has 18 zeros.
Yes, so this would be a 2 followed by 18 zeros.
How about PID number 3 that we see here in People's 8 that has a number 12 in the lower left corner? Again, another stain from the patio area. Did you obtain a result for that particular stain?
Yes, this DNA profile is also consistent with the DNA profile obtained from Fabio Sementilli, and it was the same statistic. So using 15 of 23 locations, the DNA profile obtained occurs in approximately 1 in 2 quintillion unrelated individuals.
Okay. What about the stain that we can see here in People's Exhibit 7? Has a 41 in the lower left corner. Looks like it's on the door jamb area leading to the patio from the kitchen.
Yes, so this was a red stain on the back door interior door jamb. This DNA profile that I obtained from this item was also consistent with the DNA profile obtained from Fabio Sementilli, and using 15 of 23 locations, the DNA profile obtained occurs in approximately 1 in 2 quintillion unrelated individuals.
Looking at the stain inside the kitchen under PID 12, in People's Exhibit 7 with a 29 in the lower left corner, a stain on this drawer here, the exterior of the drawer. Did you obtain DNA results for that particular blood stain?
Yes, I did.
And what was that?
So we call this a swab of reddish brown stain on the cabinet. This was consistent with a mixture of 2 contributors, meaning that we had DNA from at least 2 different people, including at least 2 males. The major DNA profile obtained from this item. So a major DNA profile is sometimes when we're able to perform a DNA analysis, we can determine a major profile. So we can see that there's the DNA from 2 people there, but based on the intensity of the peaks that we get during our analysis, so when the DNA profile is actually coming off the instrument, the raw data, we're able to determine a major profile. So it's a DNA profile that's much more intense than the other. So in this case, we were able to determine a major DNA profile. And the major DNA profile obtained from this item was consistent with the DNA profile obtained from Fabio Sementilli. So using 15 of 23 locations, the major DNA profile obtained from this item occurs in approximately 1 in 2 quintillion unrelated individuals. The DNA profile of the minor contributor cannot be determined. So I wasn't able to do anything with that minor contributor, that second person.
The major contributor, that just means that individual looking at the peak heights contributed more DNA to the stain than the other, the minor.
Yes, so the intensity of those peaks of that DNA profile was more intense, so I was able to parse out that separate DNA profile.
And this also was a stain that tested positive for blood?
Yes, this was also positive for a presumptive test for blood.
Looking at the stain that we see on the leading edge deadbolt in Exhibit 724, PID 14, this red stain that we can see here, you were able to obtain results from that particular stain?
Yes, so we called this reddish stain from the garage door leading a deadbolt. So the DNA profile obtained from this item is consistent with a mixture of 2 contributors, including at least 2 males. The major DNA profile obtained from this item is consistent with the DNA profile obtained from Fabio Sementilli. So using 15 of 23 different locations, the major DNA profile obtained from this item occurs in approximately 1 in 2 quintillion unrelated individuals. The
So-
sorry.
I'm sorry, go ahead.
The DNA profile of the minor contributor cannot be determined.
Okay. So again, you had one individual who contributed more DNA to the mixture profile than the other.
Yes.
Okay. Let me give you a hypothetical. If the killer were to have, after murdering Mr. Sementilli on the back patio, came through the kitchen, through this door that we see here, where we have the PID 14, and went into the garage and had blood from the victim on his hands, would that be consistent with the type of stain and results that you had in this case?
Yes, I think it would be consistent because blood is a very rich source of DNA. There's lots of DNA in blood. So when you have something, let's say for just touching an item, like if I'm touching this microphone or my notes here, I'm less likely to leave behind DNA from touch. It's not as rich of a source of DNA as blood. So if there is blood on my hands, I'm more likely to leave DNA behind from that blood than me actually touching the item.
So if we talk about touch, we're talking about skin cells, right?
It could be skin
Sweat.
cells. It could also be sweat. It could be some saliva, just because we do a lot of things with our hands. Like I run my hand through my hair, I could cough. So there's lots of ways we deposit DNA onto our hands.
But that is a less, as you said, rich source than perhaps what we would find with blood or semen.
Yes.
All right. Let me ask you about another sample, looking at people 7. It has a 37 in the bottom left corner. If we look at PID 16, this little blue rag, did you obtain any results from this item?
Yes. So this in my report was called cutting from a reddish brown stain on the blue towel. Item 23, PID 16. This DNA profile matched the DNA profile obtained from Robert Baker. The DNA profile obtained from this item occurs in approximately once in greater than 1 septillion unrelated individuals.
So if we're talking about a septillion, how many zeros are we talking about here?
That's a 1 followed by 24 zeros.
Did you also test a stain from the first floor hallway closet door, PID 25?
Yes.
What was the result that you obtained, if any?
The DNA profile obtained from this item was consistent with a mixture of 2 contributors, including at least 1 male. The major DNA profile obtained from, I believe we called this the swab of the reddish brown stain on the hallway closet, was consistent with the DNA profile obtained from Fabio Sementilli.
Okay.
So using 15 of 23 locations, that major DNA profile obtained from this item occurs in approximately 1 in 2 quintillion unrelated individuals.
And again, was this a stain that tested positive for blood?
Yes, it tested presumptively positive for blood.
Same hypothetical, if after the murder of Fabio Sementilli, the killer went through the home in order to stage a crime scene and transferred blood onto the closet door, would that be consistent?
Yes.
Looking at a stain from that same area, but this time the hallway floor, PID 26, did you test that item?
Yes.
And what results did you obtain?
The DNA profile obtained from the swab of the reddish brown stain from the hallway floor was consistent with a mixture of 2 contributors, including at least 1 male. The major DNA profile obtained from the sample is consistent with the DNA profile obtained from Fabio Sementilli. Same statistic, using 15 of 23 locations, the major DNA profile obtained from this item occurs in approximately 1 in 2 quintillion unrelated individuals.
And that stain did also test chemically test positive for blood?
Yes, it was presumptive positive for blood.
Looking at people 193, there's a 16 in the bottom left corner. The stain that we see here on the steering wheel in the Porsche. Did you test that particular stain?
Yes.
And what result did you obtain?
This was
PID 14.
item 57, correct?
57 is the swab item number, and the PID
Yes.
number is 14.
So the DNA profile obtained from this item matches the DNA profile obtained from Robert Baker.
And did that stain also test positive for blood?
Yes, it did.
And did you calculate a statistic?
Yes, this DNA profile occurs approximately once in greater than 1 septillion in related individuals.
And you told us a septillion means 24 zeros.
Yes.
Okay. Let's move on to your report dated May 15th of 2018, showing you what was previously marked as People 7, page 18 in the lower left corner. Now we're talking about the manual garage door release handle. Did you test a swab of that particular area?
Yes, I did.
And what, if any, results did you obtain? This would be PID 39, swab number 42.
So the DNA profile obtained from the swab of the garage door track release handle is consistent with a mixture of 2 contributors, including at least 1 male. The major DNA profile obtained from this item is consistent with the DNA profile obtained from Robert Baker. Using 13 of 23 locations, the major DNA profile obtained from this item occurs in approximately 1 in 900 trillion unrelated individuals. The DNA profile of the minor contributor could not be determined. Sorry. Robert Baker could be included at the remaining locations, but I couldn't determine a major contributor.
So in other words, the remaining locations were consistent with his profile, his DNA profile.
His DNA profile can be seen in the remaining locations, but I couldn't determine a major DNA profile.
So if we're talking about a trillion, how many zeros is that? Or what are we looking at in terms of a number 900 trillion?
This is a 9 followed by 14 zeros.
In November of 2018, were you asked to provide a portion of the reference sample for Robert Baker to a DNA analyst on the sheriff's side of the crime lab?
Yes.
And who did you provide a portion of item 158, that swab, the 2 swabs for Robert Baker? Who did you provide that to?
Criminalist Leslie Thompson.
And do you know Leslie?
I know her from the sheriff's department, but not personally.
But you share, the
facility.
LAPD and the sheriff's department share the same building, correct?
Yes.
For the crime lab purposes.
Yes, that's correct.
I want to talk to you now about your report dated November 12th of 2020 with respect to some of the samples from the crime scene. Did you go back and use the statistical methods that had been implemented after your original reports were issued in order to update the DNA interpretation protocols using some of the newer software available for complex mixtures like StarMix?
Yes. So when we first switched to 23 different locations, we didn't have the statistical software online. But once we brought it online, I was able to go back and look at some of these profiles that I typed at 23 locations and use this statistical software to help me make comparisons using these mixtures.
Previously, I asked you about items in the hallway. Let me just go back in case a photograph is needed. Looking at the hallway here in People 752, we previously spoke about PID 25 that we see here on the a stain that looks like on the actual closet door, this tiny little red stain. Was that the stain that you previously gave us results for?
Yes, item 29 PID 25.
Okay. That was the one that was consistent with the victim. We talked about transferring potential blood or DNA onto this area.
Yes.
And looking at the same hallway, the stain on the floor, just outside the master bedroom, in People 7 with a 53 in the lower left corner. That was the other sample that we talked about that you said also was consistent with the victim in this case, Fabio Sementilli, correct?
Yes, the swab from the hallway floor, item 29 PID 25.
All right. Now, let's go back now and talk about a couple of the items where you did some recalculations. And I want to start with 14, which is the leading edge schedule. I looked at this before. People 7, there's a 24 in the lower left corner. Did you calculate the statistic using StarMix software?
Yes, I did.
And what did you determine?
So I previously said this was a mixture of two, including at least one male. So now with this statistical software, we're able to determine a few different things. So we have a mixture proportion. Mixture proportion tells you about how much DNA each contributor contributes to that DNA profile. So we have mixture proportions of 98% and 2%. So the first contributor contributes about 98% of that DNA. The second contributes about 2% of that DNA. Fabio Sementilli is included as that 98% contributor. Robert Baker is excluded from this DNA profile. So using 15 of 23 locations, the DNA mixture profile is at least 300 quadrillion times more likely to occur if it originated from Fabio Sementilli and an unknown individual than if it originated from two unknown individuals. Okay. The remaining locations were not available for comparison because of Fabio's reference.
So the new statistical methods, if you use StarMix, you use what's referred to now as a likelihood ratio?
Yes. So a likelihood ratio is essentially a ratio of two different probabilities. So in this case, it was a probability that because it was two individuals, that Fabio and an unknown individual can be included in this DNA profile versus the probability that two unknown individuals could be included in this DNA profile.
So with respect to this particular likelihood ratio, your terminology was at least 300 quadrillion times more likely.
Yes.
Okay. That it originated from the victim and another unknown individual than two unknowns.
That is correct.
Okay. I previously asked you about items in the kitchen sink. Now I want to refer you to this vinegar bottle, Heinz white vinegar, that we see here in People 7 with a 40 in the lower left corner. And did you test some swabs relative to this item?
I did.
Okay. And with respect to PID 20, looking at this little red dot here, this red stain, swab 25, booked as item number 25 under the DR. Did you obtain any results from that bottle handle?
Yes. So the swab of the handle is consistent with a mixture of 3, including at least 2 males. I obtained mixture proportions of 40%, 35%, and 26%. Fabio Sementilli is included as the 40% contributor. Robert Baker is included as the 35% contributor. So using 15 of 23 locations, the DNA mixture profile is at least 200 sextillion times more likely to occur if it originated from Fabio Sementilli, Robert Baker, and an unknown individual than if it originated from 3 unknown individuals. Because of Fabio's reference sample, the remaining loci were not available for comparison, or the remaining locations.
Okay. So the software program that you utilize now, or that you utilized here in terms of breaking down the percentages, the program actually will tell you the percentages for each contributor, correct? It breaks it down for you.
Yes, it gives us an approximate percentage of how much DNA that contributor is contributing to the profile.
Your Honor, I have a laboratory photograph of this vinegar bottle along with various notations. Be marked as Peoples 196.
Yes.
Showing you now it's been marked as Peoples 196, and there is a 2 in the lower left corner. Can you tell us if you recognize what you see depicted here?
Yes, this is, it's hard to see the vinegar bottle, but there's a vinegar bottle there. This is a photograph that was taken in our laboratory, and it's marked with where the samples were taken. So the swab of the handle that I just spoke about, in our laboratory for our tracking, we called it a LIMS number, and it's where you see that 12-4-1. That's where that sample was taken from.
Here?
Yes, and then it's pointing to where the on the handle it was taken.
The handle area here?
Yes.
Okay. And a LIMS number is just a laboratory identification management system, correct?
Yes, LIMS stands for Laboratory Information Management System.
And so that's just another way, other than PID numbers or property report numbers, of tracking a particular sample?
It's how we, within our laboratory, track samples. So it's laboratory specific.
And did you also take a swab, or did you analyze a swab of the blood stain on the bottle itself?
Yes.
And did you reach any conclusions, obtain any results regarding that item? This would be item 25, PID 20.
Yes. So the blood stain on the bottle, if you look on here, it's 12-4-2. So this was a mixture of 3 contributors, including at least 2 males. I obtained mixture proportions of 83%, 11%, and 6%. Fabio Sementilli is included as the 83% contributor. Robert Baker is included as the 6% contributor. Using 15 of 23 locations, the DNA mixture profile is at least 1 septillion times more likely to occur if it originated from Fabio Sementilli, Robert Baker, and an unknown individual than if it originated from 3 unknown individuals. And I wasn't able to use the remaining locations because with Fabio's reference it wasn't available for comparison.
Now, at a subsequent time in March of 2021, did you issue another report going back to this item after receiving a reference swab, a buccal swab, for the defendant, Monica Sementilli, from Detective Mitzi Roberts under item number 201?
I did.
Okay. And did you then go back to look at this particular item, PID 20, item 25, with respect to this vinegar bottle?
I did.
And what, if anything, did you determine at that point?
So like I said before, this was a mixture of 3, including at least 2 males. the mixture proportions were 83%, 11%, and 6%. Fabio Sementilli is included as the 83% contributor. Monica Sementilli is included as the 11% contributor. And Robert Baker is included as the 6% contributor. So using 15 of 23 locations, the DNA mixture profile is at least 1 septillion times more likely to occur if it originated from Fabio Sementilli, Monica Sementilli, Robert Baker than if it originated from 3 unknown individuals.
What was that number again?
1 septillion.
So again, how many zeros?
24.
With respect to swab 33, or item number 33, a blood stain from the master bedroom dresser, top drawer, PID 32. Was that a sample that you also analyzed for DNA?
Yes, this was a mixture of 2 individuals, including at least 1 male. I obtained mixture proportions of 87% and 13%. Fabio Sementilli is included as the 87% contributor. I have limited support for exclusion for Robert Baker. So for Fabio, using 15 of 23 locations, the partial DNA mixture profile is at least 90 billion times more likely to occur if it originated from Fabio Sementilli and an unknown individual than if it originated from 2 unknown individuals. For Robert, the partial DNA mixture profile is at least 20 times more likely to occur if it originated from 2 unknown individuals than if it originated from Robert Baker and an unknown individual. So basically, this analysis provides limited support that Robert Baker is excluded from the DNA profile, and we more often observe false exclusions in this likelihood ratio range.
I have nothing further, Your Honor.
Let's take our adjournment this time until tomorrow at 9 o'clock. The evidence replies. You have to discuss this case either among yourselves or with anyone else. If you want to discuss anything for the cause, finally submitted to you. Have a good evening. I'll see you tomorrow at 9.